Hello, this is Anthony Manning, and this is for the physics final, question 10. This was one of the create your own questions, and the focus topics was on orbital velocity, escape velocity, and the orbital period. And it's mostly framed around the idea of a satellite 112 kilometers above the surface, and then just to calculate each of the following. The mass of Mars and the radius of Mars are both needed, and I had to Google those because I didn't have those written down on my review final. But the gravitational constant I did actually have on my final review sheet. So these are actually the formulas we covered in class, and this was simply just to plug in to solve for each one of these. And for the orbital velocity on Mars at that distance, it is 3,500 meters per second in order to just remain in its orbit. In order to escape its orbit, it would be, once again, just simple, just plug in, as long as you just have the numbers, and remember to convert the, I forgot to do it up here, actually, I almost made a mistake. Remember to convert from kilometers to meters, and then from there you can just plug in, and this is closer towards like 5,000, just say 4,950, and that's just to actually escape, which is higher than, which does make sense because you can get trapped in the actual orbit if you can't actually escape it. And for the times of oscillation, once again, it's just simple, just plug in. It's just a measure of using the right formulas for each one. And then after that, I got this very large number, and I didn't actually realize that it was in seconds. And then I came back to it eventually and realized that I have to do this conversion of dimensional analysis to get it to days, just to make more sense and to be more accurate to the question in line. But those are my three answers, and thank you, Professor.